Hello, everyone. Good evening. Today we will be talking about a problem named as less or equal, time limit 2 seconds, memory limit per second 256 megabytes, etc. etc. And this is a problem of sorting 1200 something. And we'll also talk about why it is of sorting kind of problem, why the tag is sorting here. So if we talk about this problem, which is you are given a sequence of integers of n length n and integer k, you should print any integer number x in the range 1 to 10 to the power 9, so that exactly k elements of a given sequence are less than or equal to x. I know you must have not understood anything, so let me explain the problem statement to you in the most simplest manner. Suppose we are given a suppose we are given an array a 2, 4, 5, 6, 7. The length of this array is 5. Is it not? Yes, it is. And we have also been given an integer k. Suppose k is equals to 2. Okay. Now, 2 or maybe one more case, k is equals to 3. Now, what we have to do is we have to choose an integer x which is in this range from 1 to 10 to the power 9, such that exactly k elements are less than or equal to than that number x. So suppose for k is equals to 2, we if we try to think of some x, so that the number of numbers from this array are less than equal to 2. Sorry, yes, 2. Suppose if we have chosen x is equals to 2, 2. So, so how many numbers are less than or equal to 2? 1. But we want exactly two elements less than or equal to our number x. In our case, currently x is equals to 2. So k is equals to 2 and x is equals to 2 won't work. Let's say x is equals to 3. Will it work for k is equals to 2 or not? So how many numbers are less than 3 here? Only 2 still. So k is equals to exactly, because we need exactly two numbers which are less than or equal to our number x, which we are taking some random number according to ourselves in between from 1 to 10 to the power 9. So then we might take x is equals to 4. Is it possible that we get exactly two numbers which are less than or equal to 4? I think yes, 2 and 4. And these are two numbers, and exactly two numbers which are less than or equal to 4. And so they satisfy our answer. We will simply return 4 as the answer for k is equals to 2 with this array. And suppose if we take k is equals to 3, then we'll have to, maybe 4 will not suffice. I think x is equals to 5 will have to work then. So how many elements are less than or equal to 5? 1, 2, and 3. So yes, it is working. So when k is equals to 3, n is equals to 5, and this array is given, so our answer would be 5. Why not 6? Because if, of course, if x is equals to 6, then the number of elements which are less than or equal to x will be 4. 2, 4, 5, 6. Because x is equals to 6 is here. So how are we? Let's look up the test cases which are given. So first test case is let's just simply copy. I think okay. One is this. Let's remove this. Done. So now n is equals to 7 and k is equals to 4. So we want exactly 4 elements which are less than or equal to some integer x. So let's try. Uh, K is equals to 2 won't work. Sorry, x is equals to 2 won't work. X is equals to 3 will give us only one element. Then x is equals to 4 will still give us only one element. Then according to, oh, one more thing, we are not having a good loop over. Uh, so for that, we'll of course sort this array, which will become 1, 3. So yeah, you can simply see this problem, which I also encountered and then thought maybe sorting will work here. So we'll do the sorting and move on with our, creating and building a logic because I'm simply building and creating logic with you. The kind of problems which I faced is the problems which you will be facing while solving a problem from scratch. So we'll sort this 1, 3, 3, then 5, then 7, then 10, and 20. So now what we want is we need exactly 4 elements. We need exactly 4 elements less than or equal to some integer x ranging from 1 comma 10 to the power 9. It can be any number in between 1 and 10 to the power 9. So we tried, you know, we tried x is equals to 1. Will For x is equals to 1, we'll have only one element. Then x is equals to 2, still the same. Then x is equals to 3. Now we have 3 elements which are less than or equal to x. 1, comma 3, comma 3. Now let's try x is equals to 4. Still same. 1, 3, 3. Now x is equals to 5. Now we will have finally exactly 4 elements which are less than or equal to 5. That's it. So our answer would be simply 5 in this case. We could have chosen 6 also because 6 is the next x, and 6 is also not creating any trouble to our condition. Suppose if we think of x is equals to 6, still we will have 4 elements which are less than or equal to 6. So yeah, in this case, we can also conclude one more thing as an observation, which is if we choose an x, maybe leave it. We'll create observations later at the, while first we'll understand how the input and given test cases are hinting answers to us. So next is this example. है ना? n is equals to 7, k is equals to 2. Now we need exactly two numbers which are less than or equal to x is equals to some integer. Can we have k is equals to 1? No. Can we have k is equals to 2? No. Can we have k is equals to 3? Nah, only one element. Can we have k is equals to 4? No. Can we have, again we'll have to sort. Sorry that I missed that. Then we'll sort. What will be this after sorting array? 1, 3, 3, 5, 7, 10, and 20. Same. So k is equal x is equals to 1, won't work. X is equals to 2, still 1. Still one element which is less than x. Now x is equals to 1, won't work. Only one element. X is equals to 2, still same, right? Then x is equals to 3. Now here comes the crazy tricky part. So here we got 1, 3, 3, which is more than, this is three elements, right? This is three elements. But we wanted only two number which must be less than or equal to x is equals to 3 here. So in such cases where we are not able to determine an x or maybe give a proper x which would satisfy our condition, we will simply return -1 as answer. Simple. Now we will create some observations. Let's see. We have understood the questions in a most simplest manner. So we'll try to make some edge cases, understand use our understanding what we have understood from the given test cases and the understanding of the problem statement and create edge cases, handle the edge cases and build up a solution. One thing is clear, um, most of the time what we are trying to do is go to the kth element. Okay, go to the kth element. Here, which is the kth element after sorting, of course. Kth element is 1, 2, 3, 4, 5. Okay. Then the next example, after sorting, sorry, kth element is equals to 3. Okay. Then, but 3 is not working. Okay, so observations, let's create some observations now. Maybe let's say k is equals to 0. So there will be two cases, I think. Let's create some random examples. N is equals to maybe 5 and k is equals to 0. And let's have two arrays, which I am thinking. One is 2, one is 2, 1, 2, 3, 4, and 5. This is one array, A1, and this is two array, 2, 3, 3, 4, and 5. Okay. Now, in this one, we want exactly 0 elements which are less than or equal to some integer x. So, is there any possibility that we can choose x is equals to, in such a manner so that exactly zero elements are less than or equal to x? No, it is impossible, right? Why it is impossible? We have to choose a number which is greater than 1, greater than or equal to 1, and less than or equal to 10 to the power 9. And if we choose any number ranging in this, any number from this range, 1, 2, 3, 4, 5. Suppose if we have chosen x is equals to 1, but we still have 1 in the array, so this won't suffice our statement or the condition which we have. Maybe x is equals to 2, then we have exactly two elements which are less than or equal to 2. So this won't work. So in this case, uh, this will be, our answer would be x is equals to minus 1 in this case. Now considering this example, 5 and maybe let's add 6 too, because n is equals to 5. Now, or maybe one more example, let's have one more example. 3, 4, 5, 6, and 7. In this example, we can't see 1. So can we not have x is equals to 1 and have exactly 0 elements which are less than or equal to 1? Yes. If x is equals to 1 and there is no 1 in the array, rest of the elements are greater than 1. So we have exactly 0 elements which are less than or equal to 1. So in this case, our answer would be 1. Same in this case, we don't have x. We can also have x is equals to 2 answer in this for this array too. Why? Because rest of the elements are greater than 2. So that would also work. So in this case, both answer is equals to 1 and 2 will work. So when x is equals to 0, if a of 0 is greater than 1, then answer would be, okay, is greater than 1, which is this thing. If this is greater than 1, then answer would be simply 1. Simple. Else, answer would be minus 1. When not x, when k is equals to 0. This thing is done. Now, the rest of the cases, when second observation, when k is less than n and k is of course greater than 0. Okay, let's jump on this. So, what we have seen here in the above examples, that we kth element, this is kth element, and this is kth element, and this is k minus 1th element. If kth element and k minus 1th element are equal, then that would be a minus 1 case. Sorry, answer minus 1 case, impossible case, because one thing is very clear, that our answer has to be at least greater than equal to, answer has to be at least greater than and equal to, greater than or equal to kth element. Why am I saying this? You can verify with some examples. Suppose This is one example. Let's see. This is sorted. After sorting, here k is 4. Can you choose any, can you choose any x? Can you choose any x which is less than 3 or 4? No, right? Uh, uh, this is k is equals to 4. Okay, let's copy this example and go down. Proof. This is it. Let's also, okay, this is zero based indexing, of course. Zero based. So we'll be talking about in k minus 1 index because k is in 1 based kind of. So here k is equals to 4. So we want the fourth element, right? 1, 2, 3, and 4. That means k minus 1th element 3. So my argument is the answer has to be at least greater than or equal to kth element, greater than this. At least greater than or equal to. Suppose if the x is not greater than or equal to kth element, which in this case is 5, let's say maybe 4. So 4 won't work, 3 won't work, 2 won't work, 1 won't work. But exactly 5, as soon as we have greater than or equal to kth element x, we have a chance of having exactly k elements exactly less than or equal to Rx. Now there is one more case, one more impossible case. Suppose if there is a replication of 1, 3, 3, 5, instead of 7, there is a 5, then 10 and 20. So having k, what is the kth element here? Kth element is still 4, but the number of elements which are less than or equal to 5 has been increased. Why? Because there is a replication or repetition of number which we concluded as x. So we can make a conclusion here that while making sure this, sorry, yeah, this, while making sure this condition, if there is a repetition, which is if k is less than n and a of k minus 1, which is of course the kth element, but we are considering zero based indexing for the taking input. So we'll use a of k minus 1 equal to a of k, that means 5, 5 and 5. There is a repetition or the, yes, there is a repetition. So we'll simply give answer as minus 1. You won't be able to make any example out of it. Here, you can simply analyze it and observe it. Maybe let's have some, maybe k is equals to, uh, let's have k is equals to, let's not make it messy. Let's copy it and have another example. Maybe k is equals to, what if we choose k is equals to 2? Yeah, k is equals to 2. So after sorting, this is indexing, sorry, this is indexing, of course, and this is the array. And for k is equals to 2, we have to have exactly less than or equal to the kth element, which is 3 in this case. So suppose if we are going to take x is equals to 3, the smallest number, It won't work because for x is equals to 3, we are having exactly 3 elements instead of 2. That means our condition would make sense, is making sense here. Else, we will simply return a of k minus 1 as the answer, which is the kth element itself, right? In this case, k is equals to 4, 5 is the answer, right? Uh, if you want more examples, I can give you. Here it is. Here it is. Let's create a new one to prove this last one. Any random. Let's have some. N is equals to 5 and k is equals to uh, 2. Okay. Then 1, 2, 3, 4, and 5. And we want exactly, it's already sorted. So we want exactly two elements which are less than or equal to some integer x. And we know our x has to be at least greater than or equal to the kth element, which in this case is second element, and second element is 2. So the x has to be at least 2 or greater than this. So let's say x is equals to, for x is equals to 2, check the condition. Are there exactly two elements which are less than or equal to 2? Yes. So, and this is zero based indexing. So 0, 1, 2. So this is k minus 1 because k is equals to 2. So k minus 1 is the answer in the rest case. So this is one thing. Then this is one thing. Okay. And one more case, which is of course, which will also be can be concluded in it in the second case also. But let's create extra observation. K is equals to n. We know simply uh, the last element would be our answer, or the maybe any element which is greater than or equal to the kth element, of course. And then one more case, k is greater than an impossible case, which we don't have to consider it, because I don't think it will be. Uh, K is always less than 1, so it won't be a case. So yeah. So let's now move on to our code. Let's see. So we have taken our input n and k. Okay, n and k. Then created a vector zero based indexing sort. Then initialized a variable answer, and then we have used our condition which we have created. First was when k is equals to 0, we have checked if our first element of the array is greater than or equal to greater than 1. If yes, then answer is 1, else answer is minus 1. When k is of course not 0 and less than n, of course we can remove this also. This would also work, and concluded our last condition which we got through our you know yeah, exactly. So a is equals to k minus 1 is equals to a of k. Answer is minus 1. In rest of the every case, answer will be a is equals to, a of k minus 1. And then we have simply just input, sorry, uh, give the output using cout. That's it. That's our problem of the day. If we talk about the time complexity, if we talk about the time complexity, which will be because of the sorting, uh, O of n log n. Simple. And if we talk about the space complexity of the problem, it would be simply just the storing of array. So yeah, uh, O of n. Yeah. That is the end of the problem. Thank you for you know thank you for listening and hearing out the solution of this problem. Thank you.